welcome to session 2 of Unit 5. This session will introduce you to sampling and sample preparation for radioactive detection and measurements. By the end of this session, you should be able to prepare samples for the accurate measurement of radioactivity. Radioactivity can be determined by using counters like the Geiger-Müller counter, the scintillation counter, diffusion cloud chamber, electroscope, and other counters. Now, there are three main methods for collecting radiation data. The first method is a direct method. Then we have the scanning method, and then the sampling method. So let's try to explain these methods one after the other. With the direct measurement method, the measurement is obtained, or the radioactive data is collected by placing the detector near or even against the surface, or putting the detector in the media being surveyed, and then the radioactivity level can be read directly from the detector. We also have the scanning. The scanning is used to determine the radiations emitted by radioactive substances, and it is used for the quantitative detection. Now, what happens is that the detector is moved at a constant speed and at a distance above the surface of the material to be examined, and this helps to determine the radiation that is being emitted. The next thing is the sampling, which is the process of collecting a portion of an environmental media as a representative of the locally remaining medium. So the collected portion of the medium is then analyzed to determine the radionuclide concentration. Let's look at the points to consider when sampling radioactive materials for detection and measurement. So we must look at the type of samples to be collected or measurements to be performed, and this will influence what kind of detector to use. We must also look at the radioactive nuclide of interest. So what kind of radioactive nuclide are we looking for? The radioactive nuclide of interest will influence how we collect our data. You must also look at the number of samples to be collected. The amount of material to be collected for each sample is also very important and needs to be considered. Then, where are we doing the sampling? So the location of the samples. We must also look at standard operation procedures to be followed or developed. Now, when you don't follow the correct standard operation procedures, it may affect the kind of data you will collect. We must also ask ourselves, what is the target detection limit for each radionuclide of interest? And also, what measurement documentation are required? So these and any other important points to consider will be very relevant when collecting radioactive materials. Let's look at media that can be sampled for radioactive detection and measurement. So we can sample subsurface soil, we can sample groundwater, we can also sample surface water, we can sample sediments, sewers and septic systems, we can sample flora and fauna, plants and animals, we can sample airborne particulates, we can sample air, and so all these samples can contain radioactive materials of interest that we wish to analyze. Let's shift our attention to sample preparation. So in order to study radioactive materials, we need to prepare them for analysis. The samples must be prepared with care and effort, must also be made to ensure that it is reproducible. If several samples are to be compared, samples can be prepared in either liquid, solid, or gaseous form. Let's look at some theoretical and practical factors that can affect or that affect sample preparation. One of them is the type of radiation to be measured. So the type of radiation that you wish to measure will determine how you prepare your sample. The chemical nature of the sample will also have influence on how sample is prepared. Then the practicality of preparing the sample. You must also look at the availability of instruments for detection and measurement. So per your radioactive radiation you want to analyze, you must be sure that there is an instrument that is capable to detect this radiation and to measure it. We have stated early on in our previous slide that samples can be prepared in the form of a liquid, a solid, or a gas. Let's look at liquid samples. The most convenient form to measure nuclear radiation is to prepare the samples in a liquid state. In order to prepare these samples in a liquid state, there are certain questions that must be asked. One of them is, should the sample be filtered? And if the sample should be filtered, should the suspended matter be analyzed, or should the filtrate be analyzed? If the water and the suspended matter are to be analyzed, should they be analyzed separately? Or when they are analyzed separately, should the final result be combined? Also, if the sample is not filtered, what measures should be taken to ensure that the suspended matter is the appropriate fraction of water that is to be taken for analysis? Now, when all these questions are addressed, then we'll be able to have a pure and a clean sample for analysis. And so, before you prepare a liquid sample for analysis, you need to find an answer to all these questions, and you need to know what products you are expecting. As we stated earlier, one of the forms in which we can prepare our sample for analysis is the solid form. So let's look at solid samples. Now, the nature and the form of the sample to be used for analysis will depend on the experimenter and what he wants to achieve. Solid samples are well defined in size and character, and they can generally be made and handled with greater ease. Let's look at the most common methods of performing solid the most common method for forming solid samples. We can form solid samples by evaporation of an aliquot from a solution. So by simple heating, we'll be able to form our solid samples. We can also prepare the solid samples by precipitation and filtration from the solution. So we precipitate our sample of interest and then we'll filter it from the solution. Then we can also get our solid samples by evaporation of a slurry. Now when we want to produce very tiny massless samples for analysis, we can use techniques such as sublimation, sputtering, and some other methods to achieve these weightless or massless samples. So if our sample to analyze is a solid like soil, we need to ask ourselves certain questions. That is plant materials removed from the sample, because we need to do away with all plant materials that are not needed. Then that the soil need to be ground to a uniform size, and if so, what should be the size to which we need to grind this soil? Also, should stones above a certain size be removed from this soil? Should the soil be weighed as to know the mass, or should the soil be dried at a certain temperature? So we need to address these questions in order to produce a clean and acceptable sample. These are your self-assessment questions which I want you to take your time to look through them.